Okay, let's start back up again. So this one is lecture number 4A. So I've skipped us, we covered lecture number 1 a few minutes ago. Skipping 2 and 3, we're going to 4A, 4B. I'm going to cover half of 4A. Then the assignment that we're going to do, we can start it, but we're probably going to end up doing it after lunch. That's what I'm thinking. So the schedule is flexible, obviously. So don't worry about it. We'll get everything done. But we will do it later in the afternoon. Hello? Oh, oh, you're on the phone. Okay, that's why. Like, hello? Can I help you? All right, so this information here, when you're doing assignment, the first in-class assignment that we're going to do after lunch, probably. We're not going to do it before lunch, although the schedule says we're going to do it before lunch. We'll see. We'll do it after lunch. That particular assignment, however, works with lecture 4A. So all of the answers for it are in this lecture, by the way. So, and you're not supposed to cut and paste off of the internet, because some people are actually starting to work on it already, which is kind of interesting. I haven't even gone over it yet. All right, so, and here's the material that's going to relate to it. Entity relationship modeling. Okay, so what we're going to look at here is the concept of the modeling that's going to be used for our database design. We're going to look at diagramming techniques, identifying and resolving problems in the diagrams, and then how to build the diagrams themselves. So this is what the diagram looks like, actually. This is the diagram that I'm going to build in pieces throughout this lecture, by the way, as well. It is using a particular diagramming tool. You do not have to diagram for that first exercise that you're going to work with. You're going to simply answer questions about the concepts. But this is the finished product. As you can see, we have boxes and we have lines between the boxes and we have some diamonds in here. So we have different components that we assemble together, and then this turns into our database design. So we use this to build the tables that we're going to be representing. So this is working with a 3-level architectural design. So we're right here in the internal schema. So we're going to create the conceptual schema from the internal schema, and for which the users are going to participate in, or users are going to use when we actually deploy this database, put it into use, and attach it to an application for some development purposes. So basic modeling concepts. You don't have to be an artist, but modeling is sort of an art and a science. It's not like drawing. You can see we have clearly defined boxes and lines between the boxes and stuff. Good judgment coupled with powerful design tools, essentially. The models themselves, the models are descriptions or analogies used to visualize something that we can't see. That's Webster's dictionary approach to it. The data model itself is a simple representation of the complex world. So a model can take and create, in fact this model here is an entire database system. So it makes it a little bit simpler in terms of abstraction. So we can kind of see how the database is composed by just looking at the simple model. So we have degrees of abstraction, and those are the degrees in which I was just discussing in this particular picture here, with the external, conceptual, internal, and physical degree. So what we're working on is essentially the internal representing of the database in terms of its components. So it adapts conceptual model. Software dependent usually, because we're relying upon the ability to create tables to store this data in. So in terms of the concepts, the logical data model is the internal plus the external data model. And all of the pieces actually work together. And it sets the normalizations for us in terms of the design. I'm going to kind of skip through this stuff because you may read it on your own and use it in terms of your better understanding. But I'm going to assume that most people are familiar with, or for the most part, modeling in terms of the concept of it. Of what we're trying to establish. So let's take a look at the nitty-gritty details of what's called the entity relationship. So it's an ER, stands for entity relationship. Some people call it an ERD for diagram. We only have 3 components: entity types, relationship types, and attributes. So the diagram is going to consist of these 3 components. How we draw the diagrams, and the first assignment is not going to allow you, it's not going to have you do it. Second one, we're going to look at dependencies. We're going to be slightly different, but you don't know what dependencies are yet, so we'll wait for that. How you're going to draw is you're going to put boxes. You're going to draw boxes, and you're going to connect the boxes together. You can actually use Microsoft Paint for this, actually. It's not a sophisticated process, because what we have are 3 components. In fact, let me just demo it to you real quick here. If I open up a paint program, you don't have to use paint for this. You can use SmartDraw or another program, and I'll show you that in a few as well. But if I pick a component on here like a box, I've just wrote an entity. Wow, there's an entity. And then I draw the line with this entity, and I make it, you know, I could probably make this a little bit cleaner looking, but now I have an entity connected to another entity. And this is the extent of your drawing tools, by the way. If I take and I think there's one here for characters here, and I go here and I go students. Probably could make that a little bit bigger. Let me get bigger. Here we go, student. And I put student in this box over here. And then I come over here and I go classes. And I put classes over here. And then the hard part here is defining, well, what is the relationship between these two? Well, it's going to be takes or has, or so it's usually, this is usually described by one word. This is the entity. This is another entity, another word. And then we're going to describe the relationship. I could describe the relationship as takes, as an example, if I wanted to do it that way. And I could do this if I wanted to. I can open this up a little bit and then stick the word takes and put it in between, like that. Students takes, well, okay, that's really bad English. How about take? So I'm going to takes. Students take classes. And then if I wanted to, I could put a little diamond over here. And then I'd have a relationship symbol. So the diamonds, I just drew one by hand here, but you can do this on paper. If you do it on paper, you're going to have to figure out how to scan. And this would be for your homework assignments that are done outside of class. You can do it on paper if you want. And then you have to scan the paper into the computer in order to submit it electronically. Or you can use a simple program like this, like Paint, Microsoft Paint. Or you can bring up another program. And for those people who are bored while listening to me, this is why I'm mentioning it right now, we can download another program called SmartDraw. If you type into Google, SmartDraw, if you're on a Windows machine, by the way, official SmartDraw site. The only problem with SmartDraw is it puts a lovely little, I shouldn't say lovely, it puts a watermark, not so lovely, on your diagrams. I don't care if your diagrams have watermarks on them. One of the watermarks is going to say, trial version of SmartDraw, not paid for software. Okay. And it gives you 30 days. There's plenty of time. 30 days for something that you're going to do in the class. However, don't install it yet, because you don't have to do diagrams probably till Sunday. So, you know, buy yourself a couple more days of 30-day time. Probably could find another version of it, however. You could probably find another open source drawing tool. Free download. If you do the free download, you're going to have to put your email address in here, and it looks like you're going to have to sign up for it. I believe it's still free trial software. I believe it is still 30 days, but I was wondering if I could see it on here. But 15 or 30 days, it'll get you through some primitive drawing. If you're on a Mac computer, OmniGraphy is your best drawing tool. So you can go to Google and type in OmniGraphy, excuse me. This is the one I recommend. In fact, it works so well. It works like an iPad too. Wow. This is a free program without a 30-day trial that allows you to create dozens of little diagrams. So OmniGraphy for iPad too. Wow, not bad. I have to try it on my iPad. Will allow you to diagram entity relationship diagrams. What these little guys allow you to do, in fact, this picture is a pretty good demonstration here, is pick items and drag them onto the canvas and then connect them together. So all of these tools are actually fairly easy to pick up. You don't have to use any of these tools. You can use Microsoft Paint if you want, as I just demonstrated to you a few minutes ago. So it's not your artistic skill that I'm grading you on. It's, do you understand the concept of what it is you're trying to accomplish? So we also have Paint programs on the Mac, but I would actually use OmniGraphy. It's a little bit, OmniGraphel, excuse me, it's a little bit easier. It will take a few minutes. You know, here's an entity relationship diagram right here, actually. You can use more color and stuff. This is a free program, no unlimited, so there's no trial period on this either. It's basically you can purchase it, I believe, and you'll have pictures that don't have watermarks on them, diagrams that don't have watermarks on them. But for the trial software, it'll allow you to actually create the diagrams. But that will actually work as well. So your choice. So what is it that you're diagramming? Well, that's what I'm going to start into with right now. So for those people who are anxious and want to start, you can, do your Google search. You can start installing, and while you're multitasking and listening to me, you can probably get your software installed if you wanted to. Or you can pay attention to what I'm going to say. This will help you actually write the diagrams. So we have entities, relationships, and attributes. So the entity, as I was mentioning earlier, is the object. So what we're trying to do is take the real world objects and diagram them to put them into a model so that we can create a database from this model, which is where we're going to. So groups of objects of the same properties are entities. In software engineering, everything was an entity. In database design, everything is an entity as well. It's the same concept is used to model systems as it is to model databases. So it's kind of not a bad tool to actually be familiar with, especially as a software engineer or as a database person. So you have identified, hopefully you will identify, an enterprise of independent existence. So students would be a physical entity that has different occurrences as you're sitting in the class here. Entity occurrences are uniquely identifiable objects of an entity type. So we have, I don't know how many we have in here, but we have, all you guys are different occurrences of the student entity. We also have non-existence. We have entities that don't really exist in the real world. Those are conceptual entities. A sales invoice, a purchase, a viewing, an inspection, work experience. Those are all entities as well, but they don't physically exist like students exist. So classes, well, does a class really exist? Yeah, I guess we are in existence right now, but as a concept, is it more of a concept versus a physical item, a class? Versus a chair or a desk or a book or a computer, which would be physical. So don't worry about whether it's physical or whether it's conceptual. It is all the same concept, and they're all entities. So what are we doing here? We're creating these boxes I just showed you in Microsoft Paint, actually. You create a square box, and you put the entity name in there. So this would be staff and branch. So entity names go inside of the boxes. So here's what's going to happen. You're going to download a toolkit, or maybe you're doing it now, who knows. And you're going to look at that and go, well, all these symbols. There's about 5 or 6 different diagramming tool sets that are universally used. No standard in this. What I'm showing you is the simplified approach to it. You may use any symbol set that you want. Doesn't matter. Any symbol set. Because it's not the symbol set I'm grading you on, it's the concept of what it is you're creating. So as you go through this lecture, you're going to see a different symbol set than what you're going to see in one of the homework assignments, actually, and it's on purpose because it's going to show you different techniques in terms of drawing out the model. So this is pretty universal, though. All entities are normally rectangles. So some entities might actually be full boxes with information, like attributes inside of the boxes. But for the most part, a rectangle is going to be an entity. And then after we draw the entities, which is what you're going to put out first, so number one, you identify the entities. So how do you identify entities? Well, I can give you an example of a university system, because I've been talking about that already this morning. Just pick out all the nouns. So what do we have in university? It's called noun extraction, actually. We have students, classes, teachers, classrooms, books. All those are entities. All of the nouns that are used to describe the university setting, grades. So we can have all sorts of different things and components. So when you start thinking about a problem description, students take classes at the university. You can go, oh, or customers go to a branch office. What the database is really modeling are those physical entities, actually. A customer is a customer, but they're still an entry into the database. They're still represented. So, relationship types. So that's a set of meaningful associations amongst the entities and the entity types. And there might be multiple relationships between one or more entities. So it's not always a single relationship. So if students take classes, what else do? You go to bowling night, maybe? So participate in activities. So that would be a separate relationship that's associated with those two entities. So the entities themselves are defined as discrete entities. And then you have the ability to connect multiple entities as well as multiple relationships. So don't limit yourself to just a single when you start thinking about it. And it's more of a brainstorming idea, actually. Because once and it's an iterative process, because once you actually create the first version of this diagram, you're going to go back and go, oh, I left out classes, or oh, I left out bowling night or something. And then what you're going to end up having to do is modify the diagram. So that's why if you do it by hand and you scan it into the computer, you're going to have eraser marks, you're going to have this is going to be crossed out unless you just take a lot of time to do it again. So most people do take the computer route and use OmniGraphy or SmartDraw. Did you need the attendance or anything? Or no? Oh, I'm sorry. There's some people that came in late that aren't on here though. I was going to take it after lunch. But okay. But I need it back. Okay. So don't stress if you're not on there yet. We're doing it after lunch. So she just needs it for some reason. See what I told you? Being audited. That's what I'm telling you. I knew they were going to do that. I knew it. All right, so. And I'm not in trouble. Woohoo! All right, so entity occurrences, relationship occurrences, and you guys aren't in trouble either. That's good. All right, so. Okay, here's the diagram. This is what I'm talking about. So I have, this is describing staff who work at a branch. And if you get the book that I recommended, that's the book that is going to have, this is where this actually comes from. Old copies of, if you're having problems with the entire entity relationship concept and you really want to get into this as a field, then get the book, that's what I'm saying. Because the book's going to go in through all of the details. I'm just going to show you snapshots, pictures of it. So here we have a branch entity, we have a staff entity, and we have a relationship. And so most people go, well, how in the world do we identify the relationship? Well, we have a has, where we can have a takes, and you saw before I kind of changed the relationship around. It should work in both directions, but it's going to read awkward. So I can say staff has branch. No, not really. Staff work at branch. But you should be able to read it in both directions. And you can kind of see that we have two entities here. We have B003 and B007 that has two relationships, relationship 1 and relationship 2 and relationship 3, that work with staff as an entity. And a staff has 1, 2, 3 occurrences of the staff. So this is the constraint. These are the relationship constraints and the tying that we're doing to tie this branch in with the staff through these relationships. So this is the concept that you're actually trying to model. Now if we put it, this is not an entity relationship diagram, by the way. This is a model of the concept for illustrative purposes. This is an entity relationship diagram. So we have staff in one and we have branch in the other. This is not normally on the diagram where it says branch has staff. This is for illustrative purposes. This is not normally on the diagram either. This is just, again, for illustrative purposes to say that this is the relationship name. And the name is has. So first thing is we see this arrow here. You can put the arrows in or you can leave the arrows out. The arrows in basically tells you the direction you're supposed to read it. So most languages, English language goes what, left to right. So some languages go right to left. The arrow is going to basically tell you the intention of the reading. So it says branch has staff. So the arrow is put in purposely to kind of show you the it can read the opposite direction. I've seen some diagrams where they put two arrows in. That defeats the purpose because it can read it this way: staff has branch. Well, okay, so has doesn't necessarily make sense when I read it that way, which is why that arrow is put in there. So, but this would be considered a two-degree, a binary relationship, because we have two entities that are participating, and they're participating in one relationship, the has relationship. So when we talk about the degrees of the relationship, we're looking at the number of participating entities that exist. That's why I called this one a binary, because I have two. I have a staff and a branch, so it's two entities, or a degree of two. Yes. What about that? Oh, we must go to accounting first. Okay, perfect. After lunch, I'm going to record the ones that showed up late. Oh, initial. Okay, after lunch, we'll initial. Yeah. If you haven't realized, I have to do it. I'm doing attendance before and also after lunch. So if you showed up earlier, don't stress out right now. If you missed the morning, don't stress out. You'll have another opportunity after lunch. But it does get recorded that you weren't here before lunch. You missed it means that you were here, but you didn't show up before 9:15 is what the problem is. So you have to show up before 9:15 if you want to be on the morning attendance, and you'll have to show up at the time I tell you to show up after lunch to be on the afternoon attendance. Just because you're not on both doesn't necessarily mean you're automatically going to fail. We just need to track you to know when you're showing up, and it will affect your final grade if you have missed too many opportunities to sign up. You will end up with probably a much lower grade than you would if you actually showed up for each one of the check-ins. So I know it sounds like high school. I don't like it either. All right, but as you can see, the administration is what is controlling this. I have nothing to do with this. I'm just like you are. I'm just following the rules. So, all right, back to the lecture. Oy vey. All right, so the degree of relationships that we have here. We can get through this, I know. All right, so the relationship, it does make it more interesting, however, though. Anyway, so the degree of relationships. So the relationship of a degree, 2 is binary, 3 is ternary, 4 is quaternary, if I could say that correctly. We don't go past 4. We always go 1 to 1, 1 to 3 to 1. And also, I'll show you in a few minutes why we don't go past 4. You can, but it makes more sense to break it out into a separate diagram at that point. So we have 2. Now we have a binary relationship example called property owners, POwns. So you can kind of see now where this isn't really an English word. It doesn't really matter what you call the relationship. It's not grammatically, there's no grammatical incorrectness or anything about this. In fact, you can use a foreign language if you want to. It doesn't really matter. Because what you're looking at, and the reason why you're diagramming, is that you're looking at the symbols, and you're looking at what's connected with what. It could be in a foreign language, actually. It's still going to read the same way. So, what do we have here? We have private owner owns property for rent. Okay, so we have a private owner, property owns property for rent. So it's an abbreviation. If you like this technique, you may use it. You don't have to put words in there. What you don't want is an entire sentence here. So you don't want to take this here and put it down here. Doesn't work. So here's 3. So this one is 2. Another example of a 2. Here's a 3. When we have 2, notice we don't have any diamond symbol in between. And we don't have any diamond symbol on this one either. We have those arrows showing the direction that you're supposed to read it in. When you get past 2, then we put the diamond symbol in. Because the diamond symbol makes it easier to identify the participating entities. Especially if you have more than one of these on the page. You know which ones belong to which one. A fewer number of lines that you have to draw. So we have a staff who registers client at a branch. So staff registers a client at a branch, or a branch who registers clients with staff, or clients who register with staff at a branch. So the idea is you'll be able to read it starting with each one of the entities. You should be able to complete the sentence or create a sentence that would match all of the different relationships. This is different than if you were to take this client and write him out here underneath and create 2. So the first step in your entity relationship diagramming career, most people are comfortable with the binary. They can do the 2 together. And then they do a bunch like 200 2s together. And then you realize, well, if you do it that way, you're going to end up with more work. Because eventually we're going to read this and we're going to translate this into a bunch of tables. And when we do that, you're going to have a lot of cross duplicate, 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 because you're taking a 3 degree and you're presenting it as a 2 degree, which is technically a lot of duplication. Because here I can make this into 2 relationships. I can say staff registers at a branch, clients register at a branch, and then actually this is 3. Branch registers clients. So this is really 3 separate relationships, theoretically, that can be mapped out in 3 different, but that's more work. So the more you can combine together, the easier the translation process goes. So just keep that in mind. There's many different ways of drawing this. I could have drawn it in a totally different order, and I could have used different words as well. So here's our 4 degrees, and this is why we don't go past 4. We've run out of vertexes on our on our diamond. So where are we going to put the 5th? So it doesn't work. So 4 is pretty much the maximum anyway, because this is a pretty long sentence to read. Most people, at this point, it gets too complex. So a solicitor arranges a bid on behalf of a buyer supported by a financial institution. That's a mouthful, but that's enough for one diagram. Anything past that is a little too complicated. So here we have a buyer who arranges a bid with a solicitor on behalf of a financial institution. Or we have a financial institution that arranges with a buyer and a solicitor to create a bid. Or we have the bid that's arranged by a solicitor with a buyer at a financial institution. And you can basically read it in all the different directions that you want to read it into. And it's basically identifying the same 4 participating entities with, in this particular case, it is one relationship. This is one relationship as well, so is that. We're depicting one relationship with participating entities. If I were to make this into 4 separate relationships, that's when I have to start duplicate relationship, duplicate relationship, duplicate relationship. So when you don't combine them together, you end up with duplicate relationships. Because are you just talking about the same relationship, but you have different participating entities? So once you get past there, diagramming becomes a cinch, actually, at that point. Except for cardinality. I'll talk about that in a few minutes. But that's not really hard either. Then we have relationship types. So we can have the concept of a recursive relationship. So none of these are recursive, these are just with other people. So a relationship type where the same entity type participates in more than one different role with the same entity. So we have staff that manages staff. Actually, we have TAs that are students. So you have a recursive relationship with yourself. If you're a TA, you're also a student, and you're also a TA, and you're also a student. So, and you're taking a class. Well, some of you are, some of you aren't. So relationships may be given role names to indicate the purpose that each participating entity plays in the relationship. So here we go. There's a recursive relationship called Supervises with the role name. So we have staff. And here are 2 role names. One is a Supervises and the other one is Supervisor. The supervisor is a staff person. And the staff person supervises other staff people. So that's where we get. And it looks like 2 boxes. But this is, in fact, some people like to draw this with a dotted line. Because then it looks like 2 entity boxes. But it's really just one entity box called staff. And this is the relationship line. It's binary, so we have no triangle in there. I have seen people do that with the triangle, the diamond symbol. That gets kind of confusing. So when it's one entity with another entity, you just draw a line between them. This is a line, but it's kind of, turned around this way. So it can draw it to itself. You could go like this with it if you wanted to. So the way you draw it doesn't really matter, as long as you put the role names out there. So they have the role name Supervisee. So staff, a supervisor supervises. Staff, or they supervise supervisees. So this is 2 relationships. What we've been looking at are single relationships with multiple participating entities. Now we're going to go into double relationships. You just draw 2 lines. Not too bad. So entities associated through 2 distinct relationships. Well, what are they? If I didn't want to do, well, actually, we do have 2. We have staff that has branch that have staff. That's one relationship. But the manages is really a separate relationship. So the staff manages a branch. Because you can be a staff person working in a branch and not be a manager, or you could have a separate management relationship. When there's 2 relationships, you draw 2 lines. When there's 3, you draw 3 lines, 4 lines. So don't be afraid to draw more than 1 line. But then also you have to think about, well, is it really the same relationship? Or is it a different relationship? So the more relationship lines you draw, again, the harder it is to translate this into a set of tables. Because we're probably not till tomorrow going to start translating stuff. In fact, we're probably not going to draw any diagrams today either. We'll be doing it tomorrow. But then you have, okay, multiple relationship. That's all the same relationship. So you end up with the same similar problem that you do when you draw it all out without the degrees. So here we have the manager that manages a branch office, a manager, branch office with a management role name. And we have a branch office that has members of staff. So we have the members of the staff over here with the role name and the branch office over here. So we have 2 separate distinct relationships. Then we have this concept of attributes. Attributes. Well, an attribute is a property of an entity or a relationship type. Usually we have attribute domains that all come from a set of allowable values for one or more attributes. So attributes, think of them as columns in the database. And we have to put the attributes on the diagram as well. We have simple attributes, and then we have composite attributes. So a simple attribute is composed of a single component with independent existence. So student would be first name, last name. Those are simple attributes. Composite are attributes that are combined from multiple components or multiple characteristics within a given independent existence. So composites would be a combination of the first 4 characters of your last name plus your social security number or something. That would be a composite that would be created by the database, actually. That would be showing us, and you only use a composite normally when you want to link the data. So a composite attribute might be for a dependent, as an example. If you had a company and you had employees and you had health insurance policy, and you had dependents that were also on the employees, well, dependents would have to have a composite attribute to identify which employee they belong to. So that when the employee leaves the medical system, well, so should the dependents. So you can link them together, which is kind of interesting because some databases, well, you'll notice this the longer you work in the States, some databases make really weird business errors, like the employee leaves the company, but their dependents are still on the health insurance. It's like, well, how did that happen? Well, there was no composite. There was no way of linking them together. So they removed the employee off, but they forgot about, the 3 kids that were on there. So they're still getting insurance, Actually, cable companies do this a lot, too. Because they have the location of the housing, the apartment, whatever they're delivering the cable to, and they shut it off, but they shut the account off, and maybe there's multiple accounts. And so they're not actually linking the account with the location. So the location still has service, but the account's been canceled because there's multiple accounts. Because everyone who moves in establishes a new account. All the time. When you rent at a new place, don't turn the cable on until you might have cable already. Don't turn the service on. Same thing with the internet, actually. Same thing with telephone service. And because they don't have the linkage in the database, they remove the main, but they don't. Anyway, not connected to the location. There's a missed piece of information. So we have single valued attributes, and then we have multiple valued attributes. A single value holds a single value for each occurrence of an entity type. So if I were to say in names, these students have first name, single value, last name, single value. If I were to say classes, you have multiple values because hopefully you're taking more than one class. Probably taking 2 classes and CPT or something else along with that. So you've got multiple items, which is multiple attributes, so they're going to be holding multiple values for each one of the occurring entities. Then we have derived attributes. Your age is a derived attribute, given the date of birth in the current year. That's how we get your derived attribute. Also, maybe your status. Are you current student? Are you on probation student? Are you, what's your GPA is a derived attribute. No one's going to store a GPA in a database because it's a derived attribute. And so you can create derived attributes from single valued attributes or from multiple valued attributes, but it's derived, which means it represents a value that's derivable from a related attribute or a set of attributes, not necessarily in the same entity type, actually. Then we have the whole concept of the keys. All this stuff, by the way, is represented in these entity relationship diagrams. So your keys, we got candidate keys, primary keys, and composite keys. This is just the terminology for you. A candidate key is any key. It's a minimal set of attributes that uniquely identifies each occurrence of an entity type. So if I had students and I put them in an entity, I could call some people actually used to use last names. Not such a good candidate key. I wouldn't call last key a candidate, but if I had social security numbers, that'd be a candidate key. If I had student IDs, that would be a candidate key. Anything that could possibly uniquely identify you as a unique entity occurrence is a candidate. A candidate means it has the opportunity to become a key, but it may not be a key. Those are good, but you want to remove extra candidates when you start building tables, and we'll go through that when we start translating the tables, because it's nice to identify a candidate, and it's nice to remove a candidate, because a candidate can cause confusion, going back to what I was saying before. If I queried you guys and I queried your candidate key of a social security number, it's going to be a different number of people that are going to come back who may or may not have social security numbers, but if I query student IDs and another candidate key, I'm going to get probably a different number. So that causes confusion and problems. It's not necessarily, it's a design flaw, actually, or a design issue. And then we have the primary key. Most people are familiar with primary keys, especially if you've taken an undergraduate course in databases. And everybody knows about the primary key. It's the one unique key that's going to be used to identify the entity type. However, a lot of people don't designate it as a primary key. When we create the tables, we're going to say this is a primary key. You can create the table and not put the constraint in there and not use it as a key, but it's still a key. Bad design. Because when you put it in a primary key, you're saying this is the primary key, and then you're going to link it to a foreign key. And when you create the table, you're going to say this is the foreign key that relates to this primary key. Then you have the solid linkage. And if we're talking about database design, that also in terms of Oracle improves the query speed and the functionality. Because every single database is automatically indexed on the primary key. You don't designate a primary key in a table, you just build the table. Oh, it works. You can create table, space, table name, blah, 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 blah. You create a table and not designate a primary key, no index on that table. Which means your query speeds are automatically, originally, right from the get-go, is slowed down to nothing. Especially the more you populate that table. You designate a primary key in that table, Oracle says, oh, index it. The index automatically gets created. When you go searching through the table, it searches the index, and it creates a much more efficient, faster lookup for that table. So the usage of the table is actually enhanced. And then you also have the constraint that's enhanced, because you have that foreign key, so you can't put anything in the foreign table that doesn't correlate to the primary table. Which means when we join tables together, we can actually join them correctly. And we'll get errors if we don't put the right stuff in there, so we're guaranteed that we're going to be able to join things correctly. So a concept associated with this when done poorly or not done correctly is if we had students in the registration table that weren't students at the university. We could easily accomplish that by not designating primary and foreign keys, because a student could essentially just walk through the door. I'm not quite sure why anyone would do this, but sign up for a class and not be a student of the university. Because there would be no requirement for them to have a primary key in that table over there when they joined this table over here. Which we actually had at one point. In fact, then we would have a problem with, you're a student, right? And yours is your second year, perhaps. But they can't find your first year courses. Because it's lost. Because there's no foreign key in the table that would link you up directly. There's no direct linkage between the two tables. Which means, and your ID got changed, your student ID got changed, or your profile got updated, and all of a sudden now we don't have a linkage. We actually had that in the LMS, but it was corrected. But they were creating new LMS rules and accounts and stuff, and then where's my classes from last term? Uh-oh, because there was no linkage between the primary and the foreign key that would provide the constraint. So it's for integrity, it's for constraints, it's for efficiency, but it's also for making sure the data is going to be consistent and correct, which is kind of important. But people leave it out because it's not really a requirement, right? You can create the table without designating a primary or a foreign key. Composite keys are keys that consist of two or more attributes that can be created as a composite key. So, which is different than a primary key, because what if a primary key doesn't exist? Then you can automatically create a key in the table that's a composite type that you can identify from the entity relationship diagram. That's going to be something like the last 4 characters of your social security number with the first 4 characters of your name or something like that, which is what people like to use the last name, and they like to use social security, or they like to use something else to create it. So, or what's not on here is the candidate where there's no composite, no primary, but people use an index value. Bad idea. Bad idea. In fact, that's why a lot of people don't like student IDs. What does your student ID tell you about yourself? Nothing. It's a randomly generated number. If I have your student ID, I have no idea who you are, actually. Because there's no way of deriving anything from that. It's just a random number, which is really not considered a good idea. But in this particular case, it is. Because we don't have any other key choice. Because all of your last names are going to be very similar. Some people even have the first, in fact, even American names you have, you know, similarities in the names. And then you also have similarities in everything else. So which in university settings, it makes sense to have a customer ID or a student ID as a concept. So, all right, so here's our finished diagram. It is a two relationship diagram with a binary, two participating entities with two different roles. And now we have the attributes put into the boxes. One way of doing it, we can also write the attributes out here and connect them together with lines. In fact, actually, let me show you real quick. Get rid of this one. Oops. Hold on one second. I forget I'm in a window here. If I go back to my lovely, lovely little diagram here, I can do this. And connect them this way. You'll see this a lot, actually, which is why I'm doing it. And then in here, student, oops, don't want that one. With this one, I can go date of birth as an example. Put that in the big box. Student ID. So these are attributes that are associated. If you're doing this in Paint, this is the easier way of doing it, I think. Or may not be, because if you also, you can do it this way. So, there we go. We can see here. I'm actually getting more proficient at Paint, it looks like. It's a little cleaner. I can go in here, and I can go date, no, classes would be time, day, I don't know, number, oops, day, well, okay, you know what I'm talking about. I can list the attribute, duh. I can list, actually that would be D-A-H, if we're going to say that correctly, duh. I can put them in here, and these are the attributes that are associated with it. It's the same thing, it means the same thing as this, but I put them in little bubbles and connect them. It's all preference. This is the old-fashioned way of doing it. When object orientation came around and this entity turned into an object, people got fancy and they created 3 boxes here instead of 2. And they went, oh, let's put the attributes. And these are the attributes, by the way. The third box would be the methods, if we were to translate this. Because here's another thing we can do, and I haven't shown you yet. We can take this entity relationship diagram and translate it one-to-one into a class diagram. So you're learning UML class diagrams at the same time. Because this entity is an object, and the relationships are the associations. And it's a direct translation into UML class diagrams. If you're writing it like a UML class diagram, however, you're doing it this way. So the lecture is actually showing you the more standard modern day approach to doing it, for which we're actually creating a class diagram out of it. But don't call it a class diagram, it's a database diagram. It's an entity relationship diagram. So we have our primary keys, and we use an abbreviation PK inside of opening and closing curly brackets, if you're going to do it this way. If you're doing it on the old-fashioned way, you underline it. So if it's in a bubble, you'll see it underlined. And I'll have some examples of that coming up as well. And then you see composite here. So an address has a composite attribute of a city, state, zip code. It's called a composite, and it's designed as a composite because what would the city make any sense with outside of the address? It doesn't really. It's a city. So if you put it all together, you can say, give me the address. If I give you the address, think of it like a hierarchy. Inside of the address, I'm going to have a street, city, and a postal code, or whatever it is I have. And then we have a multi-valued attribute for a telephone number. We can put that in as a multi-area code, prefix, suffix, extension, anything that might be associated with that. So, and over here we have the area to list the attributes in, which is this lower box here. And then this derived attribute, which is going to be total staff. Total staff isn't going to come in from an entry that we're going to update. It would be senseless to put a total staff number in this particular box. So instead what we're going to do is designate this, and we're designating it as a derived with this backslash, excuse me, this forward slash that's in here. So this is going to be total staff. So this is lecture 4A, by the way, and this is what you can use as a reference when you start writing your diagrams for certain styles that you might want to use. When you get the symbol sets, OmniGraphy is going to give you this. SmartDraw is going to give you the bubbles. It may also give you this, but you can tweak it. So you don't have to follow the tool set that you're using. You can make it look, or you can use paint. You can make it look any way that you want it to look, is what I'm trying to tell you. Believe it or not, out in industry, you'll see a variety, depending upon whether or not they're object-oriented. If they're object-oriented people, you're going to see it done this way. You know, this is the more modern way of doing it. The old-fashioned way is with the little bubbles. So entity types. We have two different types of entities. And by the way, just in case you're wondering, we're going to do exercise 1 after lunch, because I decided I'm going to continue with this a little bit longer. So when we come back from lunch, the first thing we'll do is the first exercise. And I'll go over the exercise when we do the attendance and stuff like that. So don't stress on it right now, because a lot of people are looking at the schedule going, "Are we supposed to do exercise 1 before lunch?" No, not yet. So I'm running a little bit behind schedule. Now I know first day is kind of going to be a little slower. So plus maybe we'll be doing surveys too, who knows. All right, so entity, and we're going to break at 12 noon, which is in about 20 minutes or less. So strong entities versus weak entities. A strong entity has to have an existence, so it is not existent dependent on other entities. A weak entity relies upon another entity to exist. Going back to the health insurance example, if we have employees who are working for a company, those guys are strong entities. How could you not be a member of the system? You know, unless you're not. You're either on or off. You're either working for the company or not. A weak entity would be a dependent who's on the health insurance policy. They're not going to exist unless the employee exists. So going back to the example I gave you, if we delete that strong entity, we have to have some sort of an association with those weak entities. If we don't, the weak entities are going to be part of the system, but the strong entity is gone, which is not really a good idea, actually, for business purposes. So here's another example of a weak entity versus a strong entity, where we have a strong entity type called client and a weak entity type called preferences. So preferences are over here, client's over here. So the client states its preferences. This would be like, you know, if you had settings for a website, or if you had you know, filled in the color combinations you like, or the, you know, like for a dental office, the preferences would be like, you know, you want Saturday appointments, or, you know, you like this dentist or that dentist or something, which might not exist. You don't have to have, to be a client, you don't have to have preferences set. So the preferences table and the preferences entity would be considered a weak entity in this particular case. They both have the same characteristics to them. They're both entities. But one of them is weak because it wouldn't exist unless the other one existed. So, and then we stay states is the relationship. And there's a relationship between the weak and the strong entity. Usually the weak only has one relationship with the strong. And it's a binary type of relationship, obviously. So with a single valued relationship. Here's a relationship called Advertises with attributes. So remember I said attributes are on the entities, and these entities here, and these are called attributes that are associated with it. We also have attributes that could be associated with relationships. So here's a relationship called Advertises. Newspapers advertise property for rent. So we have property number over here, like student ID. Over here we have the newspaper name, the publication, blah, blah, blah. And in the Advertises relationship, we have the date of the advertisement, the cost of the advertisement. So these are attributes, and you notice there's nothing in here. There's no box up here. There's no label because it's not an entity. And you see the dotted line that's going to the Advertises relationship. Because when we translate this down into a set of database tables, we're going to have to take this relationship, because we haven't gotten to cardinality yet. I'll do that after lunch. Or actually I might be coming to it soon. But this may turn in, sometimes the relationships turn into tables, and sometimes they don't. This one, I can tell you ahead of time, it's going to turn into a table. The other ones we've looked at before aren't. They get tossed out. Only the entities turn into tables. But this one's going to turn into a table. And when we turn it into a table, we're going to include these attributes in the tables, which is why we're specifying them here, which is interesting. So we put the name of the entity up here, and then we put the attributes that are associated with it underneath, so we can kind of tell what's going on in terms of that. So, and use the dotted line, actually. So you can also do the same technique, by the way, with bubbles. So you can put bubbles up here, you know, the little oval things with the names of the attributes and lines that go in here. This is a little cleaner looking, though, a little bit more professional looking. So. Structural constraints. So now we're looking at multiplicity. Main type of constraint on the relationship is called the multiplicity. So think of number of participating, or number of in terms of multiples. The number or range of possible occurrences of an entity type that might have a relationship with a single occurrence or associated entity type of another and that participates in the relationship. They don't have to be the same. We can have many different students, many different classes, but only one teacher who's teaching all those classes or something. So it's not dependent on the degrees of the relationship, of the participation. And participation, by the way, is also another term that's being used in here. We have mandatory participation, and then we have optional participation. In an optional participation grouping between an employee of the company, we have optionally participating weak entities called dependents. Because it's not mandatory that the employee have kids to work for the company. Or it's not mandatory that those kids be on the health insurance company. What if the spouse of that employee has a better health insurance policy? And the dependents are on that policy, not on this policy. So we have to identify participation in terms of mandatory or optional, which are the two terms. And that translates itself as well into object orientation. And that gives us a little bit more of the object-oriented design details as well. But it's also used in entity relationships. And I forgot to mention it because it hasn't been, it's coming up further, but I thought maybe I'd just mention it at this point. So the multiplicity is giving us our business rules. And so they're called the business rules. It represents the policies established by the company and the rules that are associated with it. So as an example of participation and multiplicity, each class has a maximum enrollment in it, which is a business rule that says this class, in fact, some people who wanted to take this class can't take this class because we've met the participation requirement, which means we had X amount of students who were the business rule that designated that. But for the table of students that's going to be associated with this class, it only goes to a certain point. And which is also another piece of information that gets recorded. So the most common degree of relationships is binary, 1 to 1. We can also consider 1 to 3 as well. The same rules apply, but we're normally looking at a 1 to 1 kind of multiplicity relationship, where the binary relationships are generally referred to as being a 1 to 1, 1 to many, or many to many. And I'm going to show you examples of all these scenarios in a few minutes, but here's a 1 to 1. So staff manages relationship here, where staff manages a branch, and we have one staff person with one relationship with one branch. And then we have another staff person over here who has one relationship with the branch. And what does that look like in the diagram? It looks like this. And down on the bottom of the thing, this is the kind of the concluding sort of big gotcha in terms of getting your diagrams correct. It's getting the multiplicity correct and being able to understand what in the world this is talking about. One of these numbers actually is talking about participation, and then the other one is actually talking about the number of degrees of participation. And we get that when we start looking at more examples. But the primitive one here says, same diagram as before, we have a staff that manages a branch, and this is just one of the relationships, by the way. You would include the multiplicity for multiple relationships. So each relationship line that you put on the diagram includes its own set of multiplicity that's associated with it. So we got 1, 0, 1. 0 is going to tell me it's optional participation, actually. 1 is going to say it's mandatory. At least one is going to be having a relationship with at least one branch. So if I were to read this English, and this is where the multiplicity is being diagrammed with these numbers down here. And each branch is managed by one member of the staff, which is where we get the 1 to 1. So sometimes you'll see this with a colon in between, up and down, like in the previous slide here. You'll see it written like this. That's acceptable. You'll see it written like this. This is acceptable. I'll actually just put a 1 or an asterisk, or leave it blank. If you leave it blank, it's 0. If you put a 1, it means it's a 1-to-1. If you put an asterisk, it means it's a many-to-1. And it's only one of the components. It's not telling you about participation. And then the assumption is it's mandatory participation. But I'll show you that shortcut in a few minutes as soon as I go through the different scenarios. So this is where you'll see all the differences and the ways, different styles about how people diagram. So we have two different relationships. Well, no, we don't. We have one relationship with two different multiplicities associated with it. Because over here is a member of the staff can manage 0 or 1 branch, which means it's optional participation on the staff. A staff member, to be a staff member, does not have to manage a branch, which means that optional participation, which is where that 0 comes into place. But the staff person is only managing 1 branch. So we can't manage more than 1 branch, just 1 branch. So that's where that 0.1 is coming to. Don't trip on it too much, but this is really not talking about this over here, but it is talking about this over here. It's talking about the level of participation with this over here. It's all about this over here, which is why this is over here next to here. Well, did that sound right? So this here is over here next to this here, because this here is of course associated with this here. It's really talking about this over here, but it's not. So it's interesting. Because you'll see this when we come up with 3, and you'll go, what in the world is which one talking to? If then we had another guy up here, another entity, and we're going, well, which one is this one going to? This one or this one? It's not going to either one. It's going to the combination of both of them together. So we'll see that in a few minutes. So now we have staff that oversees property for rent is our relationship here. So we have staff over here, 3 different relationships, but staff over here, he's got more than 1 property for rent over here. So that's where the asterisk comes into place, so 1: asterisk, or 1 ... asterisk. We all have 0, which means it's optional participation. Here we have 1, and then you're going to look at this and go, what does this mean? Well, it's associated with this guy over here. And this 1 is talking about this guy over here. So each property for rent is overseen by 0 or 1 staff member. 0 or 1. So this property cannot be overseen by more than 1 staff member. But more than 1 staff member can oversee more than 1 property for rent, which is where you get this asterisk over here. So each member of the staff oversees 0 or more properties for rent. Why do you need to know any of this? Because when you create those database tables, this is going to specify when this relationship turns into a table and when it doesn't. Because the uneducated person takes everything and turns it into a table, or they don't take this route at all. And they don't know that they don't need the table. The smart table, the educated person takes and looks at the cardinality and the participation and also the multiplicity. And then you know whether or not you actually need the table or not. And it's part of the reasoning that you're going to go into. And then it reduces, because what you really want to do is have the least number of tables to accomplish the task and have the most relationships represented. In order to represent the most relationships, you have to break some of those tables out into multiple tables. But how do you know when you have to do that? And when it's necessary versus not being necessary? Well, that's what the multiplicity is giving you, actually. This may not necessarily be necessary. Well, that doesn't make sense either. Necessary. Is it necessary to be necessary? All right, but we'll see as we go through. We're just starting. I haven't gone through the translation yet. When you go through the translation, this will make a little bit more sense, I believe. But all right, so we have each member of staff, 0, optional participation with many. So we have the asterisk over here to show many, because I can show many. So now we have newspapers that advertise property for rent with a relationship type, where we have many newspapers with many different properties for rent. And so now we have many to many over here. So now we have, instead of one staff person per property for rent, we have newspapers over here now. We have maybe have a newspaper that doesn't have any properties for rent in it. It's possible. You know, back when the economy was really good, we didn't have any properties for rent. And you just take the section out of the newspaper because it's empty. You don't need it. So, which means it doesn't have to. Newspapers are not required to show properties for rent. But each property for rent advertises in 0 or more newspapers. So we have an asterisk over here because we have more properties for rent that are going to go into this newspaper, but they don't have to go into this newspaper. It's optional, which is where that 0 comes into place. And then each newspaper advertises one or more property for rent. So one newspaper, each newspaper has one or more properties for rent. You could make this 1 into an asterisk to say that multiple newspapers have multiple properties for rent. And then that's where you have to make the decision, what's the business rule? How many newspapers do we have? Because here's another classic example. You have a database, and you're going to keep track of airline flights. And each flight only has a certain number of seats in it. If you make it unlimited, you're going to oversell too many seats on that airplane, which they do. They sell seats on airplanes for seats that don't exist. The seat holds 25 and they have 50 on the flight, which means not all those people are going to take that flight, but they're breaking the business rule when they do that. If they had the business rule correct, they could book up to a certain point. Well, if the rules over here said that you can only list it in one paper, if you list it in multiple papers, you're going to get in trouble. Well, same rule would apply towards those airline seats. If you book more than one seat on that same plane, you're going to get in trouble. But lift a rule, make it everything. So here, if we wanted to, we can make it everything. We can list that paper. List the property in more than one paper if you want. It doesn't have to be one paper. But one paper is going to have more, one newspaper is going to have more than one property for rent normally. So it's about business rules. That's what my story is. Long story short. So then we have the structural constraints is what we're getting to here. Multiplicity gives us our structural constraints. The number or the range of possible occurrences of an entity type in an n-array relationship with n-1 values are fixed. So in terms of multiplicity, we can look at this again and go, well, this guy here is a staff member, but he's not, doesn't have any clients. I don't know, maybe this guy's on lunch break or something. I don't know. We're going to be not having to listen to me soon. But this person over here has got 2, this person has 3. You go, well, that's not fair. Well, here we have 3 of them together, and we're looking at this. Now we're going to go, well, what does that mean? This is a 0 over here because it's a 0 over here. If we put a 1 on there, this guy can't exist in the system, which is a business rule. But it's also a constraint. So if it's 0, then we can have staff people. We can have a spot where we have no clients, and then we have any number of clients. And this is where we're seeing the 3 degrees in here, where any number of clients can be with one staff person at one branch, which means these clients can't reside at different branches, and they don't actually. The clients' numbers are registered at one branch only with one staff person, but one staff person over here has multiple clients. So when you read this here and you go, well, what does this mean? If you go up with the relationship, you have to backtrack it. So a client or no clients. If we're going to have a client, we can have as many clients as we want, and they can register with one staff person. And 1, 1, what does that mean? Well, 1, 1 is going to match over here, 1, 1 branch. So this is what you'll be doing in some of the assignments, so you get some practice doing this. Because this actually turns into 1, 2, 3, 4 tables. So, which if you did this incorrectly, it would be 3 tables. But this is really a 4-table database. So this relationship doesn't always turn into a table. And we don't actually, in this particular case, we don't have to put attributes because there are no attributes associated with that relationship. Instead, we're going to end up with a staff table, a branch table, a client table, and a registration table. And the registration table is going to be a composite of all these 3 with no attributes of its own. So the registration table is going to have staff number 1, branch number 1, client number 1. It's going to be nothing more than a table full of 3 keys. No extra data, which is going to put this in third normal form, actually. So before the break, I just leave you with the thought that although you can put attributes on the relationship, not such a good thing because sometimes the relationships don't have attributes. that are associated with it, which is why in most of the diagrams that I'm going to show you as examples, we're not going to have attributes associated with it. This is a good one to stop at. I'm going to stop here after this slide, a summary of multiplicity, because then I'm going to starting with cardinality and participation, which is going to be a little bit, you don't need this for the first assignment. So we're going to stop over here. This is just a summary of the different types in terms of when you see 0, ... 1, this means 0 or 1 entity occurrence. 1, 2, 1, or just 1. This is what I was saying before. Sometimes I'll just put 1 here, or I'll put 0 here, or I'll put an asterisk here instead of putting 2 numbers. It's assumed. And it's only giving me one of the 2 components that I'm looking for. There's 2 distinct components that are part of that numbering system, which I'm going to cover after lunch. But you'll see different styles of it. Here we have a 1 to many, many, and many. Here's 5. If I were selling tickets for an airplane, I'd say that this airplane table is allowed to have 0 to 25 seats if it's a small plane. You know, you don't want to oversell tickets on a bus, tickets on a plane, or in a classroom. 0 to such a number of students can enroll. So you can actually put a number here instead of using 0s and 1s or asterisks, especially if this does not unlimited. So the asterisk is the wild card that says it's unlimited. A number is a number, so that's going to be setting the limit. So, all right, so we're going to take a lunch break because it's 12 o'clock noon exactly on my clock here. And I'm going to end this video so people watching this don't have to hear about the lunch plans.